towards throwing this in our calculator. In F1, we put the original function, cosine of x minus x. In F2, throw the derivative, negative sine of x minus 1. All right, so cosine of x minus x. It's kind of fun, bless you. Negative sine of x minus 1. All right, we have those in your graphing menu, yay? What did I say minus x? Oh, I sure did, thank you. Okay, that's better. Okay, so remember now your goal is to start a loop. So start by storing 1. Did we say 1 is our initial guess? Store 1 into x. Now you do Newton's method, or type in Newton's method and store over your old x. So what do? You go 1 x minus f1, which is the function at x, and then I divide that by f2 of x, which is the derivative at x. And before I hit enter, I don't hit enter. Instead, I say take that result and store it to x, therefore writing over your old x with some new x. When I hit enter, it'll show the first time that does it. That's the first iteration. 0.750 is my first estimate of the root. Write it down, 0.750. Your second iteration, write for the person what you will do. The second iteration of Newton's method is x1 minus f at x1 over f prime at x1. When you do that, your second estimate is, hit enter again, 0.7391. Do we all agree? Okay. 91. That's an x that is pretty close to where cosine and x have the same value. All right? All right, go to 15, please. 15 is a good question to help you practice for the test on Wednesday. It is differential equations. Yes, does that work for you?
No.
Thursday.
No. Wednesday.
Wednesday it is. What? What's happening?
I don't know what's on Wednesday.
We have Thursday would be no homework.
Thursday. Thursday.
No homework. No homework. Let me look at the calendar as far as what has the least stuff on it, and we'll. Thursday? I just thought you would have a lot of stuff on Thursday because teachers want a long weekend to grade. According to my calculations, on Thursday there is nothing. There doesn't say there's a physics midterm. All there is AP BC Test 3.
Yeah, I have that. But
Should we have it on Wednesday? I don't have, there's nothing shown on Wednesday or Thursday. You have a physics test Wednesday? What? That's ridiculous. Okay, so it sounds like a little of everything, yeah? So let's go with Wednesday it is. All right. I'll be happy to give you your Thursday homework at any time.
No.
Wednesday, you can do it Wednesday night. How's that? Okay? All right, so go, do this. This is on the test, go.
Oh, I don't want to.
Differential equations are a big part of calculus anyway, but also the examples. Yep.
Is this where we find the general form?
I want when they say solve for y equals f of x, you're expected to get the particular solution.
Okay, so we do general then particular then.
General, then particulars, and solve for f or y. Sometimes students have a hard time separating the variables here. Yes?
So for particular solutions, that's the one where you solve for y?
No, particular solution means there's a given condition with which you can find the c. This here, this is what tells you to solve for y.
Don't look at me like I'm dumb. I'm aware.
That's what says I want a function. Okay? Were you able to get started on separating? How do you change e to the x minus y?
Natural.
That's how you do it.
Darn it.
No, it's not.
Now you should be able to separate.
Don't listen to ding dong.
Do you ever just make up rules for math? I feel like this should be a rule today. I just invented a new math.
Kind of scary.
I feel like you should be
You do
aware.
that when you're driving too? This is a red suspect. That's the next one rule. It must be what I do. Should we take mercy on Gary? Oh, you'll love parking back. It's so great. Okay, let's go. Separate, go, go, go. What'd you do?
Y equals x.
E to y dy equals.
Dx, dx.
Okay, integrate. What do you get?
E to the y.
Use 1 and 1. What does that tell you C is?
0.
Okay, then what? Exponential or log, and so y is? All right, cool. Okay. So here we go. Is this out of order? Where's this slide? Okay. So, how are you at volumes? Are you good? Good. If you're good, then you'll be good today. If you're bad, then say it will get much worse. There we go. So what are the first 3 volumes we've done so far? Disk. Disk is when the area is right up against the axis of revolution. Okay? The basic idea is the sum of many r squared d whatevers for the height. What else?
Washers.
Washers. That's when there is a gap around. Volume is pi, big R squared minus little r squared, and again, D something for the height of the washers. And what else?
Shells.
Shells. Volume is 2 pi times the radius times height, and then the thickness of the papers is there. All right. Cool. Now then, if when you draw a figure and draw a rectangle or a sliver like that, which for the life of me I cannot get some of you to do, and they're made very thin, then all of a sudden that delta x becomes
Zero.
dx. If the rectangles are done this way, then that delta y gets thinner and thinner, so the slices looking like this become dy. Further, last big idea, volume should always be positive. To achieve this, you don't break out the big eraser and erase negatives. You say horizontal components should be right minus left, and vertical should be upper minus lower. If you do that, well, you should always get positive answers. Now, today, then, is a little more complicated because you're not going to go around the x-axis or the y-axis anymore, or as much. You'll also go around different axes of revolution. It's all good because at the very least you won't have oblique axes of revolution. That is considerably nightmarishly hard. So be grateful. I can tell you that they won't get too bad. All right.
But I wanted to
Yeah. Oh, it's
Google it.
yeah. No, it's you should. It's lots of fun. But no, it's beyond the scope of our class. All right. So say you have. Is this the first example we have? Okay. So say you have this region here, the square root function, and y equals 1/2 x. This example is meant to be such that those meet right at 4, 2. Up 1 over 2, up 1 over 2. There's that wedge-shaped enclosure. You're down? All right. So far, same as always. But now, look what it's revolved around. This is revolved around the line y equals 2. That's the axis of revolution. So if I revolve, then it would go whoosh, and the reflection would be more like this and this. That's not good. I'm going to try it again. So go up to 4 on the axis. So the top is straight and the bottom is curving. And it says using x. All right, so if we're using x, then what kind of sliver or rectangle will we do? Up and down or side to side?
Up and down.
Up and down. If I do an up and down rectangle and revolve that rectangle, then I get a washer. All right. So I'm glad you can recognize the figure. That's after the picture. That's the first thing, is to say, all right, I know it's a washer, so I know it's this blueprint, and because we're using x, it's dx thick on the sliver, yeah? Or the slices.
Yes.
All right, let's go big R. What is big R? Now, big R is the distance from the center to the outside. What is it? 1/2 x. Almost right, except it's dead wrong. Right? It's 2 minus 1. Upper minus lower. Okay? So, wouldn't you, so let's just pretend there's lots of slices here. So, I think you'll agree that there is some kind of slice at this point, yeah? And maybe it's a place where the y value is 1/2. What's the radius? Pi. Thank you. If this is 1/2 and this is 2, isn't this 2 minus 1/2 or 1 1/2? Okay, so here, the radius is 1.5. There's probably also a slice where the y is 1. Isn't then big R 1? Because 2 take away 1 is 1. Every time to find big R, I'm going to take the whole distance 2, subtract away the line to leave me with big R. So upper minus lower is 2 minus x, 1.5 x. Upper minus lower. Right? Now, what about little r, which I will do highlight here. Here's little r, or here's little r. Upper 2 minus the square root of x. And the limits of integration, are they 0 to 2 or 0 to 4? 0 to 4. Would you throw that in your calculator so that we can verify our second answer as well? Don't forget the pi out front. The more complicated the problem, the more likely people are to forget the pi. So 4, nope. 2 minus 0.5 x squared minus 2 minus Did you get 8.3775? All right. 8.3775. You do need to practice this because it starts to get gross putting in your calculator. Are we good? Okay, now let's try the same problem using y as the variable of integration. So sketch the region. Sketch the axis of revolution. All right. Now let's talk R. Or sorry, a slice. If it's y, then doesn't the rectangle go this way?
Yes.
Reflect and revolve a slice. If you take a slice that's parallel to the axis of revolution and revolve it, you get a shell. Yes? All right. So volume is 2 pi, and we need the radius to complete the circumference. Remember, 2 pi r represents the circumference of the revolution, and the height, and then the thickness. So, what's the radius?
2 pi times 2. Yeah, 2 minus
2 minus, so is it 2 minus the line, or 2 minus the square root function, or neither? 2 minus y.
Wait, what are we talking about?
What's the r? The radius of the cylinder. It's 2 minus y. Upper minus lower. For example, when I look at this slice here, when the y is 1, isn't the radius 2 minus 1 or 1? And if the sliver is at y of a half, isn't the radius 2 minus a half, so 3/2. So it's always 2 minus y. Cool?
Yeah.
Right? The height, and by the height I really mean the height of the cylinders, which runs this way. Right minus left. 1/2 x. What's the variable of integration? Y. So it's the line minus the curve in y terms. That's right minus left. So 2y minus y squared. And the limits of integration? 2. Throw that in your calculator, you better get the same answer. Plus. So this is just to kind of get your feet wet day. Tomorrow we're just going to do tons of these, and you'll get closer and closer to mastery. So hang with me, and it'll be good. Hopefully you got the same thing, yes? Okay. Shirley, if you got something different, then you did something wrong. All right. So far, so good? Okay. So these are volumes around a horizontal axis of revolution. That's not the axis. Let's try a volume when you do around a vertical axis of revolution. Like y equals -2. All right. So same region. Give yourself room below the graph because you're going to go below, far below the axis. 2, 4. Get that same kind of banana shape. Then locate the horizontal line, y equal -2. Now as far as the reflection, wasn't that low point 2 away from the axis of revolution above? So the reflection will go 2 away from the axis of revolution below. So that reflection should start at -4. You follow me? All right. Now we could draw the whole thing, and that's cool, but really I just want you to focus on the slice or the rectangle. If I use x as my variable of integration, do I do an up and down rectangle or a side to side rectangle?
Up and down.
Up and down. So do an up and down rectangle, or 2 if you like. Do a reflection, and then connect the 2 pieces of your rectangle to see what you get. What do you get?
Washer.
There's a washer. Then get a blueprint for the washer. Pi big R squared minus little r squared. Oh, sorry, these are not vertical lines yet. Vertical lines are later. I wanted to do one below the axis. All right, sorry. So our limit's 0 to 2 or 0 to 4? 0 to 4, because we're working with x. All right, so think for yourself. Don't shout it out, please. Think for yourself, what do you reckon big R is? Think for it. And what do you say big R is? Square root of x plus 2. Where's the upper minus lower?
It's the
Minus -2 is plus 2. That actually makes sense because I know square root of 2 is this much, and then it's 2 more than that, so it's more distance. That's all logically, eh? All right, little r is probably a little easier now that you've thought of that. What's little r?
1/2 x plus 2.
Minus -2, which is plus 2 there. Throw that in your calculator, please. Shout it out.
104
719? 105 point, 25.133? Okay, got your mistake. There are lots of places to make mistakes here for sure. Okay, you try. Find the same volume, but this time using y as the variable of integration. Ready? Okay, obviously we know what the answer is, but we do need to know the details. What's your radius? Y plus 2. It's y down to the axis and then 2 more. Upper minus lower is y plus 2. Part of the confusing part is, do I use the curves or not? Well, you do use the curves in one of the places, but not yet. The height, which is this distance, that's where you use the curves. Right minus left in y terms is 2y minus y squared. 0 to 2 or 0 to 4? 0 to 2, then make sure you use the y values. And did you get that same 25.133?
Yes.
Okay. Yes.
Why is it y plus 2
2y plus 2? Why would it be 2y plus 2?
Because of the equation to the line.
Oh, okay, I see what you're saying. So, do you agree that this sliver I'm showing is about, let's just say it's 1.2, yeah? What's the radius here? Isn't it 1.2 plus 2? So the total radius is 3.2. So in terms of the line or the curve, I didn't really use the equation of the line there. I just said, what's the y to the axis, and then 2 more units. So it's all just about whatever the y is at 2. The line comes into the right minus left. All right? Let's try going around a vertical. This should, does yours say horizontal? That should say vertical because x equals 2 is vertical, dummy. And by dummy, I mean me. Sorry, not you. Okay? So, if you show this region with a lot of room on the left, please leave yourself some room on the left. Because x equals -2 is a vertical line over there. And then we have to have room for the reflection on the other side of that mirror. So the innermost point, isn't it going to be 2 away from the mirror on the other side? So at -4, x equals -4. Yeah. You down?
Yes.
Okay. All right. Now, I'm saying use x. So what kind of rectangle do I draw? Vertical rectangle. And its reflection. Is that a shell or what? It's a shell. Okay. 2 pi RHD something. And now the details. All right. So, what's the R? So, I think you'll agree that somewhere there's a slice when x equals 1. When x equals 1, what's the radius going to be? When x equals 1, the radius would be 3. Yeah. When x equals 2, the radius would be 4. When x equals 3, the radius is 5. So it feels like the radius is always whatever the x is at 2. Or you could say right minus left. X minus -2 is x plus 2. Okay? And yes, it's tempting to say, well, what about the line? What about the curve? Well, it's coming. Be patient, youngster. What's the height? Yeah, that's upper minus lower. That's where we're talking the root minus the line. Limits? 0 to 4. Still the original region, always the original region. Try that in your calculator to get an answer to check our B with. Or part B with. Unless it says otherwise, you may use a calculator on these in homework. We'll focus on the concept of setting it up, not the integration skills. What did you say, Ben? What did you get?
I got 3.
3.159? Okay. I remind you, you could put units on this, but as a matter of habit, we just don't on the AP test for strategy-wise. They just recognize it. But it's cubic units if you were to do it. Would you try the same problem using y as a variable? If you got this for part A, proceed on to part B. If you didn't get that for part A, talk to me, let's figure out why not. And we're getting a washer. Okay, it's big R. What'd you get for big R, Cindy?
2y plus
2y
2
plus
plus 2.
2 for line minus the axis of revolution. I agree. And the inner R, y squared plus 2 from 0 to 2 or 0 to 4. And you got the same answer, yeah?
Yep.
Okay. The last concept is axis of revolution right of the region. Throw the region down. This time you can see the axis of revolution is taking me way right, like that. Did you do that volume of revolution, both x and y? We'll compare answers and we'll move on to questions at least. I want to get 91 or 92 turned in. So about 36.861. Okay. I could be wrong. That's entirely possible. Okay, you agree? Ready?
No.
I don't hear a lot of, yeah, I got 36 coming in. Lindsay?
Yeah.
Oh, shoot. Okay. All right. So let's go with A. Let's check at least your word for A. What's the radius? First of all, do you agree with the shell? Okay. What's the radius? Right minus left. Right minus left. The right on all these is always 6, and the left is always x. 6 minus x. The height is upper minus lower.
Root
x minus 1 half x, then don't forget that x is 0 to 4. That should get you 36.861. Okay? Now let's go to y. Okay, if it's a y slice, are you getting a washer?
Yes.
Alright, so now we need to get big R, right minus left. Right minus left. So the right is always 6, the left is
Y squared.
some point on the curvy curve. So 3 minus y squared. Now the outer point is this for root. Just checking, make sure you're with me. Alright, you got it. 6 minus y squared. The inner is always from 6 to the line. 6 to the line. So 6 minus 2y. And hopefully that is also 36.861, though I did put it in. Are we good?
No.
All right, questions on 92. 92 is due today. 93 is tomorrow's a fun sheet day, so we can get caught up on 93. So let's just tell me 92. Questions on 92. What? There's more?
Oh, wait, there's more.
Yeah, there's more.
If you act now.
We'll do it tomorrow. We'll do it tomorrow. All right, 92, go. 12, 14,
Act now, we can.
25.
What?
Wait, there's more. Oh, wait, there's more. You have 12. 12 replaced. 12 replaced. Okay, we can get through all these if you help me out and participate. So, 12 is not replaced. It's normal book problem. Yes. Okay. So y dx equals or minus dy equals 0. Yay. Were you able to separate the variables to get the x's and dx's on one side and the y's and dy's on the other side?
Yes.
Okay. So, how do you do that? Y dx, so I hear maybe move over dy and then separate. dy over y. Okay? In doing this, the dy should never be in the denominator, ever. Differentials are always in the numerator. So if you integrate this,
You get X.
equals natural log of y plus c, eh?
Yes.
And did it say anything else about general differential? Oh, same differential equation, find a particular solution to 2, -1. Okay, so did you put 2, -1 in? 2 equals log of the absolute value of -1. C is 2. X equals natural log of the absolute value of y plus 2. We need to solve it for y. What do?
You Go subtract 2.
Subtract 2, how do you get rid of natural log? Exponentiate e to the x minus 2 equals absolute value of y. Absolute value doesn't go away, it's still there. When you dump the absolute value, it's plus or minus, and how do I choose? Based on the initial condition, when x is positive 2, y is negative 1, we choose negative. Y equals negative e to the x minus 2. Understood? Okay, 14. 14 is normal book. Okay, so this you definitely have to collect your facts well. When they say there's an inflection point of 0, -3, that actually is two things. First of all, it tells you that when you put in an x of 0, that -3 is left right away. That's telling you c is -3. It also tells you that the second derivative is changing signs at when x equals 0. And because it's a polynomial, it's probably the case that the second derivative is 0 there. So if you take the first derivative is 3x squared plus 2ax plus b. Alright, I'll have to help. If you have more questions, I'll have to come in. You have to come in some paragraph. So this is due today. I don't get it, please. That actually tells you that a is 0. Oh well. Darn it. I guess I need to go faster. I should dump my warm-ups.
I gotta see it.